Hello everyone. In this episode we will install all of the panels, install the cables and hook up the inverter. And hopefully we will also be able to hook it up to the grid as well. Welcome and hope you enjoy. So the first step is done. Panels are all installed using small clips. And the cables come up from the ground and with connectors here. All around, connecting it at the end. So two different circuits, one for facing west, one for facing east. And in series all the panels. Nice installation. There's an underground cable to the second structure. So the panels facing east on both structures are connected to the one circuit, and the panels facing the other direction on both structures are also on a separate circuit. And the cables come in here and go into the garage. So it's not so far, not so long cables. And if we have a look inside, cables coming up here, and a nice installation. All hooked up to the inverter, but as you can see, there it ends. So next is to connect it to the grid and to power it up and then start producing. They say that the Huawei might have a problem with Wi-Fi, but let's see. I have an access point actually in my garage, and it's a Unify. I'm pretty sure it will work. Otherwise I will just add an extra cable for that and take it down to the inverter. So not a big problem. So I made one special thing here actually. As you can see, there are 2 extra cables here. And the intention for this is that I will use them in an emergency. So in the other end, they will be connected to only 2 panels, or depending on what backup system I select, if it's an EcoFlow or something else, depending on how much voltage it will handle, I can have 2 or 3 panels or more. And then in an emergency I can just disconnect, and I can connect this one to the EcoFlow, and I will have a battery backup that I can charge from my panels. I don't need any extra panels for that. So I think that's a very good solution. So here are my backup cables. They made them a bit short, so they have to be a bit longer, and then we have to add connectors to them. So in an emergency I would basically just have to disconnect 1, 2, 3 panels with these connectors and hook up my backup, and I'm up and running. It's really an easy backup system. So the panels, you can see the model here. So it's the end of day 1. Inverters all hooked up, not connected to the grid yet, but that's coming. The DC cables are hooked up, and of course all the panels are installed, and it's looking good. So far so good. I want to give you a bit more detailed explanation to why I didn't go for batteries, at least now. My inverter can absolutely handle batteries. I can connect up to 15 kilowatts of batteries into the inverter. Looking from a backup point of view first, it's not really what I expected, and that's the reason why I didn't go for the batteries. What you need is a backup controller, and the backup controller will basically switch off the grid when there's no power at the grid, and it will switch all of the generated energy to a separate circuit, and this is a one phase circuit, not hooked up to the central, and in fact it will switch off the normal 3-phase circuits that I have for my house. So it's not really what I wanted. It will be a separate circuit. I need to connect the things that I want to use in an emergency situation to the separate circuit on the backup controller, and that's not really optimal for me. I still think it's good to have batteries to be able to decide when you consume and generate energy over the day, depending on the energy prices and so on. So I might consider it in the future to have it for that reason, but then it will require the grid being available, of course.
So, but in terms of a backup solution, it's not really what I want. So what I decided to do is to go for a very simple backup solution. This is my setup today, 32 panels, 2 PV strings. Each PV string has an output of 760 volt. So what I want to do is, in an emergency, I will simply disconnect 2 of the panels and connect them to another battery backup system like an EcoFlow or something similar. And since these systems typically only can handle up to 100 volt or something, I can only use 2 panels, but that will be enough to charge the EcoFlow or the separate backup system. And these can also be extended, so I can potentially have more than 2 kilowatts can be extended with external batteries and so on. And the advantage of this is that I don't need to have the whole battery set up, which is quite expensive. I can have a simple solution, it will be cost efficient, and it will also be mobile. I can bring it anywhere, and it will have different outlets for charging USB devices or using AC equipment and so on. And it can be used in other applications as well. I can use it daily on just charging it from the grid directly and having it ready if the power go away for just a few hours or something. And it will not require any extra panels or anything. I can just use my solar panels that I have in a real emergency. So I think this is the best I can do right now. I will monitor my consumption during the day and my production during the day and see if I need batteries for that reason to be able to control my production and consumption during the day. But I will add on later if I see the need for it.
So another day, getting ready for the electrical installation. So the electrician will come today and he will hook up the inverter to the central. And then we will also start up everything and make it running. So hopefully we'll be done today. So we have hooked up the inverter. There's a connector coming with the inverter. It goes to a safety switch. So you can turn off the inverter and basically the production of that is going out to the grid. In the central there is another switch, so you can turn it off, and of course the fuses, 3-phase, it's also here. This one is also new, since I'm going to put in a charger for the electric car, so it's prepared here, and it's, since we are in the garage, it's the right place to have it. So we're done with the installation. Everything is ready to go. And the first thing we want to do is to start it up. And to start the system, we first want to turn on the DC to the inverter. We'll do that. And then we will just give it a few seconds to start running. It will be running on the solar. And here it comes. Start blinking. Now we want to turn on the AC. This will hook up the inverter to the grid, and it will also start the production. So when it's booted, it will start to produce directly into our grid, and the energy that I'm consuming will of course not go out to the grid. It will be consumed directly, and the rest will be sold to the grid. This is a sub-central, so it's hooked up to the main central in the house. And there I have the energy meter and so on. So the sub-central from the garage comes into the main central here. And it has separate fuses here. And then we have the energy meter here. So and this is a new one that will be able to handle the production as well. And as you can see, I have an extra thing here. This is from my Arduino project where I'm monitoring the energy meter. So if you follow my threads about Arduino and building Magic Mirror things, then you will see it there. There's a separate video on this.
So finally, I'm happy to show you this picture. We're actually up and running, and we're actually producing. You can see that I'm currently producing 2 kilowatts, but it has been running for a few hours now. And if we look in the diagram here, I think the top was 8.8 kilowatts at midday. So that's really nice. And then it's getting lower and lower now. And already, if it's just been running a couple of hours, I'm almost producing 20 kilowatt hours. That's good. We can see this is the Fusion Solar interface. So I have an app on the phone as well, where I can see all of the data. Capacity 12.8 kilowatts in peak. And then we can have a look at the devices. We go to device management. So 2 devices. One is just a Wi-Fi adapter. That's a dongle attached to the inverter. And then we have the inverter itself. And here we also get a lot of data. You can see there are two different PV connections. So I have 16 panels in each, and right now they are about 500 volts. So it's going down everything now. It's getting a bit darker. I think normal production it will be over 700 voltage here. Then there is also some additional information you can get from this interface. This is the total if you have several different setups or inverters. For those of you who are watching my other video series about Magic Mirror and Arduino and home automation and so on, you understand that I must show this picture. So what happened on the Magic Mirror right now is that I'm consuming exactly 0 kilowatts. That's extremely nice to see. And of course, we need to update this to show what I'm producing and so on. And I will also be hooking up my inverter using Modbus TCP to the Magic Mirror. So watch out for those videos if you are interested in that video series. But I like what I see here so far.